So just to see how this is going to work, let's look at a specific case. So in this 45, 45, 90, let's go ahead and say that one of these sides is 5. So if one of the sides is 5, something that we also know about this triangle is that since the base angles are congruent, it's actually another type of triangle as well as a right triangle. And you guessed it, it is isosceles. So that means that this guy is going to be 5 as well. So not only did we know that this was 5, but the other one is 5 too. So obviously we can use Pythagorean theorem to solve for that hypotenuse now, but I want you guys to see what pattern is going to happen here, because we aren't going to use Pythagorean theorem once we figure out these patterns. We're going to use the special right triangle shortcuts. So if we've got these two sides that are 5, let's go ahead and do Pythagorean theorem and just see what our hypotenuse ends up being. So we set it up and we'll go ahead and make the hypotenuse x. So I've got my 25 plus 25, so I've got 50. And then when I take the square root of both sides, I'm going to get that my x is the square root of 50. And then using the simplifying that Miss Beasley went over yesterday, or in the video before, sorry, we can break this 50 up into a perfect square, 25 times 2. And then we can take the square root of 25 to get 5 square roots of 2. Okay, so we had both of our legs were 5 and 5, and then we ended up with a hypotenuse of 5 radical 2. So maybe there's a connection there, but we really need another example to see. So let's look at our next example. We've got a side that's 6, so same situation where because it's isosceles, I've got that other side that's 6. I'm sure allowed to use Pythagorean theorem, but remember we're trying to figure out this pattern. If I set up my Pythagorean theorem, it's going to be really similar to the last one. I've got my 36 plus 36 is 72. Oh, I wanted to go ahead and take the square root, sorry. I'm taking the square root of 72. I'm again going to have to simplify. So I'm thinking of my perfect square that goes into 72, and it is 36 times 2 is my 72. So that means that my hypotenuse in this case, my square root of 36 is 6. I'm left with the radical 2. So in this case, I ended up with my legs were both 6, and my hypotenuse ended up being 6 radical 2. Remember in that first one, I had legs of 5, and my hypotenuse ended up being 5 radical 2. This is not a coincidence. 45, 45, 90, this pattern that we're seeing is going to happen every single time. So whatever your legs end up being, maybe we know the leg, maybe we know the hypotenuse, but if we've got the legs, then the hypotenuse is going to be whatever that is times radical 2. If we were trying to go the other direction, so say on this last example, if I had my 6 radical 2 for the hypotenuse and I was trying to figure out the legs, then I would just do the opposite of multiplying by radical 2. So I would divide by radical 2 if I wanted to go from hypotenuse to a leg. Okay, so let's look at some examples. This is definitely, if you write down anything, I would write down this right here for 45, 45, 90, because that is, in general, what's going to happen with all of them. We're going to use that shortcut. So go ahead and write down this first example. This is a case where we've got, sorry, I dropped my marker. This is a case where we have a leg, so very easily from this we can see that the other leg is going to be the same. So we automatically know that our x is going to also be 12. By the way, sometimes they'll do this where they only give you one angle, but really they give us 2 because we've got the 90 and the 45, so we automatically know that the other one is 45. So that's what tells us, yes, it is going to be isosceles. And then using the pattern that we talked about, if I know that the leg is 12, then my hypotenuse is just going to be 12 times radical 2. And that's it. That's my x and my y. So we're kind of using the fact that these are special right triangles, that they have a shortcut, there's Jack, that they have a shortcut to where we don't have to use Pythagorean theorem every time. We can use the shortcut for these, and that does save a lot of time, especially in upper level trig. So for example 2, something a little different. This time we have the hypotenuse, we don't know the legs. Something that is helpful here is that our legs are still going to be the same. So I'm really just having to solve for one thing. So I'm saying my x and my y are going to be equal, but what is it? So since I have the hypotenuse and I'm going to a leg, I'm going to do my opposite of multiplying by radical 2, which is to divide by radical 2. So I've got my 7 divided by radical 2. And then I always have to remember to simplify my radical because I don't want it in the denominator. This is where that radical lesson comes in. So to simplify, I want to multiply by that radical 2 over radical 2. I'm going to end up with a 7 radical 2. Remember that I'm multiplying these and ending up with a radical 4. And then that's always going to be a perfect square. So I end up with a 2 in the denominator, and this is what x and y both are. If you want to skip this step right here, it's not really a big deal. So if you go straight from the square root of 2 times the square root of 2 is just 2, that's always going to happen. So it's fine if you skip that step right there, but just so that we're comprehending what's happening there, I'm going to keep it in. Okay, so that's example 2. For example 3, sometimes you will have radicals in your problem already. Don't panic, you just have to know how to deal with multiplying, dividing by radicals, and then you're good to go. So since we have the hypotenuse on this one, that radical 10, same thing that we did on the last example. Since I'm going from hypotenuse to leg, I'm going to be dividing by that radical 2. My x and my y are going to be the same, just like they were on the last one. Oop. So I've got my square root of 10 divided by square root of 2. I just have to know how to deal with this, and since they're both radicals, you can kind of think of this as them all being under the same radical, if that helps. And then I can simplify this to just say that the square root of 10 over the square root of 2 is just the square root of 5. So both of these legs would be the square root of 5 and the square root of 5. Hypotenuse is square root of 10, which makes sense if you work it the other direction, because if we multiply that by square root of 2, yeah, we're going to end up back with the hypotenuse is square root of 10. So when it comes to 45, 45, 90s, we are always asking ourselves, okay, am I going from a leg to hypotenuse? Because that means I'm going to multiply by radical 2. Or am I going from hypotenuse to leg? I'm going to divide by radical 2. That's really all there is to it. And then always simplify.